last time we made it so that, well, we just did a bit of refactoring last time. We just moved stuff about from file to file, but basically we've got the ability to call functions on scripts with native code stuff. Here we go. What have we got? We've got these functions foo1, whatever, and we can call them down here from native code, and we can pass parameters to them. Problem at the moment is, though, we can only pass parameters by value. So these 1, 2, and 3 parameters we're passing in get copied about. There's no way of passing in like a larger structure and having Lua operate on that structure, which we should be able to do because we have this sprite class that we've registered here. We've registered sprite, there it is, this test class that we've got. We have registered that with Lua, and we've got it so that you can make one of these in Lua and you can call the functions and use the public methods on it. So we should be able to do that. So let's just go in and, well, let's just jump in and see if we can actually, let's see what happens when we do this. So we'll make one of these sprites in native code this time, and then we'll pass it to a function in Lua. So the way you might do this is you might have a bunch of sprites or things in your native code, and you might actually have a script that you run on each one. So you might make a script for each one and then call that script. So it's possible that you might have a render function. I don't know. Probably wouldn't, but it serves the purpose. You might have an update function or something like that. So let's imagine there's a function called render, and we want to pass our sprite into it, the sprite that we have made in native code. It's just sitting right here on the stack. But let's just do that. Let's make the function that we're going to call. Let's just copy this. So it's called render, and it takes a sprite, and the sprite we'll just call draw on it, which we can do because we've mapped all this in our code. So that's really what we want to work. We want to be able to do that. So let's see what happens when we compile that. It should compile, I think. Yep. So what's going to happen when we run it? It's a miserable failure. So why did that fail? Let's have a look. Let's just go into the debugger. Why has it failed? Put on Lua stack. So this is the thing that accepts the parameter, and to Lua unhandled type being sent to Lua. So we've only handled int and short, and we haven't handled the other types. But there's another problem before we even get to that. Where is it? In our automated binding, this is our call script function, and one of the ways we left it before, we're trying to get pass by reference working, and one of the problems is we're passing copies in anyway, even to this function. So we've already copied the sprite even before it got to Lua. So the first thing we've got to do is fix that. So I think I can just fix that by passing the arguments by reference. I have to do that in all these other versions of this function as well. So whenever I pass the arguments to this call script function, we pass by reference, which calls put on Lua stack, pass by reference again. And there's another one here, pass by reference, and that one doesn't take any parameters. So the first thing I need to do is make sure I don't copy the thing I'm passing through when I call this function straight away. So that's introduced a compile error because cannot convert from int to int reference. And now we've lost the ability to call with these literals. So this 1, 2, and 3, we can't do that because it wants a reference to 1, 2, and 3. So we've kind of lost a little bit there, but I'll stick with it for now, and we'll assume that we're not going to have that at the moment. But let's make these into actual values. And let's pass those instead, which should work because we can have a reference to these. So you can see that like trying to get pass by reference in has altered the way we've had to call this other code. It means we've lost the ability to do literals. So we can try and get that back, or maybe that's something you don't need, or we don't need. It could be. So let's see if that compiles. So yep, that compiles, and it's still a failure. It should be failing in the same place as before, I think. which is to Lua, unhandled type being sent to Lua, which was what was our type? I don't know. It was our sprite. I assume it was our sprite. So first thing we should probably do is try and handle that error. So if the thing is it's not a void, because this can be used in other situations. If it's not an int or a short, I think we can ask for these. This is a variant, this result, an RTTR variant. So this is part of our runtime typing information. I think we can ask we can get type and get the type on it, and we can ask it if it is a class. So we should probably do that, because what we could assume is that if this thing isn't an int or a short, then if it's a class, we want we can assume it's a class that we've mapped, and we could create a user datum for that, which is what we do with the sprite when we're making one. Normally we create a user datum, and then we map we give it all the usual Lua stuff that allows it to use it. So really what we want to do here is something like create user datum, pass it the Lua state, and we want to pass our variant in, and have it like copied into that. So we want something like create user datum from variant, and we probably want to have that return the number of values that it leaves on the stack. So that's what we want. When we pass that parameter in, that sprite in here, when we passed it in there, we turned that sprite into a variant, and now we want to turn that variant into a user datum that Lua can use, and then leave it on the stack for Lua to be able to do its stuff with, just like we've done before. Except we don't have this function. We do have a create user datum function down here, and this is the one that we use when we're actually creating a brand new one from Lua. So our like .new method is bound to that. This won't work in our case because it wants an up value. It's expecting the type, and it's going to create the variant from the type. We don't have that. We already have the variant. So really what we want to do is we want something very much like this. We want create user datum from variant. I think that's what I called it, was it? We want to pass the variant in. Let's pass it by reference again. There's the variant we're going to make it from. Let's just call it V, so it doesn't get confused with the other variant. We're not using the up value. We don't need the type to create because we already have the variant. So this part's going to be quite similar. We need to create a user datum to store the variant, and instead of creating one here from a type, we're going to copy it. So this could probably be const, I think. We're going to copy that variant, and then we need to do this usual stuff here. We want to get the meta table from the type. So actually this bit of commented out code is actually what we want here, I think. Could we do that? No, let's not do that, because we've already got the variant that we copied. We can use this to get the type. So let's get the type from that and pass it into this thing, because this function just gets the name of the meta table. That's all it does. We pass it a type and it just gets the name of the meta table that we need to, well, Lua needs that meta table to be bound to this, otherwise it can't call any of the functions on it or do anything. And that's just the user value, so that's the same thing. There is a problem with this though. You see this one here. This is expecting that the first thing at the top of the stack is going to be the user data, and I don't think it will be, because in this case this one's called from Lua, but we're calling this one ourselves, so there could be anything on the stack at this point. So what we need to do is, just after we've created the user datum, we can actually just get the position that it is on the stack. User datum stack index, we'll call it like that, and you can do that with just Lua get top, and that just gives you the value, just gives you the index of whatever's of the top of the stack currently. So whether this is at index 1, 3, 9 or 7,000, it doesn't matter. We push that thing on and then this is going to give us the index to it. So we can swap that out from there and we can swap that out from there. And we could do the same thing in here, but we know in this case that it's always the top of the stack because this is a function called by Lua. So this case is okay. This one has to change because it could be, anything could be happening at the point when that happens. Is that going to compile? No, because that thing's defined down below. So I need a forward declare for that. Forward declare that there. So hopefully, if that value is a class, it's going to create the user datum and it's going to return us the number of user datums it created, which should be 1. And then we should leave it on the stack and it should be able to call it. Let's see. And it looks like it's called something because it has printed the sprite out. So x equals 0, y equals 0. I think that's what we expect in this case. So we've successfully at least called the function, which is a good start. Let's set this x to 100. Let's call it again. So there you go, x is 100 and it's drawing that. So the question really is this actually passing by reference or is it still copying? And the way we could test that is this sprite in here. We can actually do pretty much what we just did out there. But we could do this in Lua as well. We can actually do the same thing in script. So we should be able to, let's just add 10 onto it. So we should be able to add 10 to the x value and then draw it. So this render function is now a bit rubbish because it's actually gonna, this is actually gonna change the value. We really should just be rendering in there, but we're not. So it should add 10 to the 100. We should get 110, and then if we call it again, we should get 120. So this should just test that we're actually properly passing by reference. Let's see what we get. So looks like it's not working. Looks like we have actually passed by value, not by reference, because we set that x to 100. We called the Lua function. We added 10 and printed it. We then did the same thing again. We added 10 and printed it. It should be 120, but actually it's 110. So it looks like we have fully still copied this sprite when we sent it through to Lua. So let's have a look at why that is. Because we're passing by reference here. So we got a reference into here. And what did we do then? We then did put on Lua stack, which we passed by, well, it would have passed to this one here. So that would have passed in there. We passed by reference again. We're still good at that point. And I think the problem is here. And if we check the docs for this, the RTTR variant, this always copies. This always copies. So this here is the thing that's making the copy of our variant. So it's designed to do that. And that's the expected behavior. So it's not doing anything wrong there, but it isn't what we want. So what we can do is at this point here, we should get the type that we're passing in. We should get the RTTR type. And that'll be the type of T equals RTTR get. So I can get the T. So in this case, that should be just sprite. This is a reference to sprite, but this T would be just sprite here. So the type of T should be sprite at that point. And again, I can ask if that's a class. So if type of T is a class, so remember this should be sprite at this point. What we could do is rather than copying that in there, we could make the variant a pointer to the thing. So we've passed by reference here, and then we're going to pass this in as a pointer to the sprite that we passed in. And in the other case, so this will be passed by reference. And in the other case, when it's not a class, we still want the pass by value that we had before. So that's just the same code. So that will take the copy, and this will take a pointer to the variant. and pass it in. So we've avoided doing the copy on the variant at that point before we send it to Lua. So we're passing in a pointer to the sprite instead of the sprite. So let's see if we get any better results with that. And the answer is no, it's a miserable failure. So why have we failed this time? Let's go into the debugger. So we went to Lua, and what happened? So we ended up in the unhandled type. So the problem here was because we passed as a pointer, it bypassed the isTypeIn, isTypeShort, isType class. It bypassed all that because this runtime type information doesn't realize that, well, it knows that it doesn't say it's a class because it's a pointer. So it treats it differently, which again is correct. I think that's probably how it should do it. So we should I think we can ask if that's a pointer. So it knows if that's a pointer to a class or if it's a class. We're really not that bothered because if you decide to, if we decide to pass one in there as just a copy, this will still work. We've already seen that before. But if it's a pointer, we also want the variant to work. So again, rather than passing in the copy, we're going to pass in the pointer and we should still get into our code there. So let's see if we get any further with that. And the answer is attempt to index user datum value local sprite. So we've got a bit further, I think. I think we got into there. But we couldn't, that's right, it couldn't call the draw function. So it was attempting to get that draw function, or perhaps it was attempting to get this X, and it couldn't do it. And I think the reason for this is, let's have a look. So create user datum from variant. I think the reason is if we get to here, if I debug to here, I think we'll see the reason is that the type, if we go into there, we're asking for the meta, we're trying to get the meta table name for our sprite. Let's go in here and let's have a look. So this is just going to pull out the meta table name, which should just be sprite and then _mt_. So I don't know if you can see that, the font's very small, but it's not sprite, it's sprite star because this is a pointer to a sprite. So in this instance, we don't want that. We need the name sprite because it was that we registered the name for the meta table. We created the meta table with sprite _mt. So in the case where it's a pointer to a sprite, we're going to have to change the name so that it knows it's that one. So we need the meta table for a different one. So what we're going to have to do there, let's see. What are we going to have to do? We're going to have to ask if that variant, we're getting the type and we're passing that in. So we can actually handle that in here, I think, inside this meta table name. We could get the meta table name, but if the type is a pointer, is that what we want? So yeah, in there, if the type happens to be a pointer, we don't want the meta table name to be a pointer. We want it to be, I think what we can do is get raw type, which according to the docs will get the underlying type without the pointer or any const or whatever on it. So in fact, that's a good point because const might screw this up as well. So that might be another thing we'd have to handle later on. Get the raw type, get the name, and send that to convert that to a string. So we'll assume that we're not passing in pointers, but if it is, we change the name. We could handle this slightly differently. We could just do it to avoid setting this string twice in certain cases. So we get the metadata name. If it's a pointer, we get the raw type name, and if it's just the type, then we get the name. So we should end up at that point with the actual name of the thing we wanted. Let's see if we get any better with that. And I think that looks like it has done it, because we started at 100, we went in, called the Lua function, we added 10 to the sprite, and then we exited, and then we called it again, and we've actually got we're basically passing by reference there. So it looks like that is all we had to do. And the other stuff's still working, except we now can't pass literals in anymore. We couldn't pass these literals here. We had to put 1, 2, 3 in. But it looks like this is actually working. And this is actually probably, this is a much better way of doing stuff, of being able to pass this stuff by reference, because it's more likely that this is what you'll be doing in real code, is you'll actually be making, you won't be making the sprites in Lua functions, although you might do if you want to, but you probably won't make that particular type of object in there. You'd probably have that, you know, like a sprite manager or something like that in native code, and you might pass through to a call to a script function that someone else might have written to do like an update or a special thing on it. So each frame you might pass in, you know, have an update function, pass in a sprite, and someone can write scripts to actually run on that sprite for each frame. So this is really quite cool. This is probably more likely the kind of thing you want to be doing as well. But you probably do want to be able to learn how to create that thing in native code as well, because you might have smaller objects like, you know, positions or little things that you do create in native code that you might want to do that as well. But this is more like the way you're going to be using it, which is asking to call a function and passing in something native that has been bound to Lua. So we'll leave that there, but that I think that's pretty good. We've got pass by reference and pass by value currently working. So I'm not sure what we'll do next time, but we'll see about that when we get to it.